In this video, we'll use the Kohonen package to visualize self-organizing maps. First, we'll start by loading the Kohonen package. Next, we'll remind ourselves of the structure of the iris dataset that we worked with last week. We can see that we have 150 observations of 5 variables. The first 4 variables are numeric, and the 5th variable is called species, which is a factor variable with 3 levels. Next, we'll prepare the data to input to the SOM function. Since we can only use the SOM function on numeric variables, we'll start by removing the 5th column, just like we did last week, which was the species column. Next, we're going to scale our observations. Now, we'll create the grid of nodes to be used for the SOM. First, we need to specify the size of the grid. Here, I've selected 5 for both the x dimension and the y dimension. This is because we have a total of 150 observations. We want to make sure that we don't make the grid too big, or else we'll have some nodes that have no observations in them at all. Next, we need to specify the shape of our grid, which I'll choose as hexagonal. Next, I'll set a seed to ensure that my code can be reproduced by someone else. I'll do this using the set.seed function, and you can pass any number you want, so I'll pass the current year, which is 2021. Now we're ready to use the SOM function. First, we'll pass the dataset that we prepared, and next we pass the grid. There are several other parameters in this function that you can play around with, such as the learning rate. If you type $SOM into the R console, you'll be able to see the full documentation for this function. For now, I'll just use the defaults. Next, we're going to plot our results in several different ways. The first plot that we'll make will show us the number of observations that have been assigned to each of the nodes in the map. We use the plot function on the SOM object that we just created, and we specify the type of plot we'd like to make. The first one is called counts. So here we can see that we had a total of 25 nodes, and the nodes that are colored more red have less observations assigned to them, and the nodes that are colored yellow have the most observations assigned. The ones that are colored gray actually have no observations assigned to them. In this case, you might want to decrease the size of your grid, but for now, I'll continue with what we've got so far. The second type of plot we'll look at is a heat map. It's going to show us a heat map of a specific variable that we select from our original data. Let's do this for our second variable. We can see that our second variable was called sepal.width. Again, we start by passing the SOM object that we created earlier. Next, we specify the type. Here, the type we'll use is called property. Next, we specify the property argument, which will be the getCodes function applied to our SOM object, and we want the second column. Finally, let's give our plot a title. I'll make this the name of the variable that we're creating the heat map for. The heat map shows us which nodes in the map have the higher values of the variable sepal.width. We can see that this node contains observations with the highest values of sepal.width, and the more red nodes contain observations that have lower values of sepal.width. Of course, this is just for one of the 4 variables in our dataset, so we could change this in order to see the other 3 variables if we wanted to. The third type of plot we'll create is a fan diagram. Again, we use the plot function on the SOM object we created, and we specify the type. Here, the type we'll use is called codes. The codes plot shows us similar information to what the heat map plot showed us, except that it shows us all variables at the same time. So if we recall from before, the node in the bottom right corner had the highest values of sepal.width, and the nodes in the top left had the lowest values of sepal.width. Again, remember that we scaled our data before we passed it to the SOM function, so that's why our scale is centered at 0. In the codes plot, we can also see that the largest values of sepal.width occurred in the bottom right node, and the smallest values of sepal.width occurred in the top left. We can see how large the values were of a specific variable by looking at the color, and then the size of the fan within each node. Similarly, if we wanted to know where the largest values of sepal.length were, we would look for the nodes that have the largest green parts of the fan, which would be in the bottom left corner.